Hey, what's going on, guys? This is your Unit 11 test review video, part 1. I say part 1 because I know it's going to take more than one video to get this done, so let's get started. Alright, a function of the form f of x of a times b to the x is called an exponential growth. Growth. If function when the b is greater than 1, the function of the form f of x equals a times b to the x is called a decay. When the b is between 0 and 1. Alright, so a real estate agent estimates that the value of the house could increase by 4% this year. So write an equation that models the growth of the value for a house that initially valued at $122,000. So the equation should look like this: 122 times point. Remember our rates, we always convert those. So 0.04. It's 0.04. Actually, 1 plus 0.04. raised to the x. There we go. Remember, growth, you got to add 1. All right, and then this one right here, it says the house is worth $122,000 in 2016. Predict the year that this house will be worth $150,000. So you want to use your calculator for this problem right here. So on your calculator, we're going to go to here y equals, and we're going to put it in as 122,000 times 1 plus 0.04 raised to the x. And then we want to see when it's going to be 155,000. I believe that's what it was. Let me check it. So again, remember, you got to adjust your window. So I'm going to go about, this doesn't have to be too high, man. You can leave that at about 20. But you want to adjust your y because we're doing 150, so go higher than 150. 151's higher, so we'll use that. So here we go. Give it a second, it's coming. There it goes right there. So what we gotta do is find an intersection. The intersection, and what I mean is second trace. All right, second trace. Then we're going to hit option 5, intersect, and then enter 3 times. All right, and there we go, 5.26. All right, so that tells us right there that we have 5.26 years, okay? So X is 5.26 years. Sorry about that. So since X is 5.26 years, it says the house is worth $122,000 in 2016. Predict the year, what year the house will be worth $150,000. Well, we know in 2016 is this amount. If I add 5 to 2016, guys, 2016 plus 5 is going to be the year 2021. All right. So, and I'm just saying 5.26, it's an estimate, you know what I'm saying? Predict, estimate. So the year 2021 will be when this house is worth that amount right there, okay? And then this last part just says, what will the value be? What will the value of the house be in 2026? Well, in 2016, here's the value of the house. All right, 122,000. Well, 2026, that's 10 years. From 2016 to 2026. Gosh. All right, I'm going to start over. From 2016 to 2026, that is 10 years. So with my equation, same equation that we just used, 122,000 times 1.04 raised to, instead of x, we know what x is. X is 10 years. All right, so we put that in our calculator. All right, so you're not doing this in the y equals section, okay? You're gonna actually solve this one because we know what t is. All right, so you have 122,000 times 1.04. And we're going to raise that to 10. All right, because it told us 10 years, because 2016 to year 2026 is 10 years. And there we go. We got $180,589.80. Oops, I forgot. $589.80, like that. Okay. So in 10 years, or the year 2026, this is how much the house would be worth. Okay. All right. A computer valued at $65,000 depreciates at a rate of 14.3%. All right. A computer valued at $6,500 or $6,500 depreciates at a rate of 14.3% per year. All right. So write a function that models the value of the computer. So we have 6,500 times 1 minus 14.3 raised to the x, or you can say 6,500, excuse me, times 0.857. All right, because I messed up right here. Let me correct this. Remember, we got to convert to a decimal. So 0.143. There we go. So when you do that, there you go, right there. Okay. Let's just find the value of the computer in 3 years. Well, 3 is x time. So you just plug that in. So you get 6,500 times 0.857 raised to the cube. And when you do that, you get $4,091.25. All right. Now, right here, let's calculate these compounded daily. All right. So n is 365. All right. So the equation right here, P R is 0.07, and T. All right. So we have 7,300 times 1 plus 0.07 divided by 365 raised to 365 times 3. All right, and you can put that straight in your calculator just like that, okay? And I'm gonna show you. All right, so we plug it in the calculator, 7,300 times 1 plus 0.07 divided by 365 raised to the 365 times 3. Oh, forgot to tell you, put parentheses around your exponent. Alright, I don't have to because my calculator does this, but you should put parentheses around your exponent every time. Alright, and what we get is 9,005.67. Alright, now for this one, we have PR is 0.16, compounded monthly is 12, and 2 is T. So you have 55,000, times 1 plus 0.16 divided by 12 raised to the 12 times 2. All right, and again, just put it in your calculator. And when you put that in, you're going to get $75,582.25. 4 cents. Okay. For this one, 28,600. All right, times 1 plus 0.079 divided by 52, because weekly means 52 weeks in a year, raised to the 52 times 2. 52 times 2. So let's see. So what we get is 33,491.34. All right, so make sure you know what ends are, how to calculate daily, monthly, weekly, etc. Okay. All right, for this next section, we need to rewrite each equation in exponential form. Remember the conversion. The conversion is base raised to an exponent equals an answer. And then you have log of your base of your answer equals your exponent. All right, if you look, guys, that spells bay. So if you have log, you have log of bay, okay? Bay. Anyway, convert this in exponential form. That's b, that's a, that's e. So you have 6 squared equals 36. Over here, you have 289 raised to the 1/2 equals 17. Right here, you'll have 14 raised to the -2 equals 1/196. And here you have 3 to the 4th equals 81. All right, now for number 9. Number 9, it says graph y equals 5 to the 1/5 raised to the x and fill in the following. First off, is it a growth or decay? Well, when you graph it, all right, I'm going to start by doing the intercept. The intercept right here. Guys, exponential functions do not have an x-intercept, all right? They have a y-intercept, though. And all y-intercepts have an x value of 0. So if I make this 0, well, 1/5 to the 0, guys, is 1. So that's 5 times 1/5 to the 0. 1/5 to the 0 is 1, which means the answer is 5. So we have 0, 5 is the y-intercept. So 1, 2, 3, 4, 5. And then right here, because b, all right, b is less than 1. All right, this goes back to the very first problem we did. B is less than 1. All right, it's going to be a decay. So we have this deal right here. I know it's not the best drawing, guys, but you can use a calculator to get a better idea of that. So decay. Now, for the asymptote, remember, this doesn't go below y equals 0. The x-axis, it doesn't go below that. The x-axis is the asymptote. All right. Now, in behavior, as x goes to the negative infinity, which means to the left, this way, left, whereas the graph itself is going up to positive infinity. And as x goes to the right, positive infinity that way, all right, we say the graph is going towards 0 because this keeps getting smaller and smaller and smaller, but it will never go past 0. Finally, the domain of exponential functions, guys, is all real numbers. And then the range, remember the range, it can't go past that asymptote, but it goes up from there. So we say that y is greater than 0. Now, we're approaching the 15-minute mark, so I'm actually stop the video. Tune back in for part 2, okay? Make sure you use this, man, as a study guide, man, for the test. And I really hope to help, all right?